Hey guys, today we're talking about the quadratic formula. Ooh, the beloved quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. You've heard some better songs about the quadratic formula in the past. I'm not a very good singer, if you know what I mean. So, quadratic formula, first of all, allows us to find the solutions to a quadratic equation. In other words, when ax squared plus bx plus c equals 0, the values of a, b, and c can be used to find these solutions. Graphically, they're the x-intercepts. Now, what is the quadratic formula in case you missed it from my beautiful song a minute ago? It goes like this. It's the negative b, or opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the value of a, where a, b, and c are found in your quadratic equation when it's set equal to 0. Okay, so when we say to solve a quadratic, it simply means to find the values of x that make the quadratic equation equal to 0. In other words, where it crosses the x-axis, or the x-intercepts. So let's practice. We want to solve 10x squared minus 13x minus 3 is equal to 0. In other words, find the values of x that make this, or where this quadratic equation crosses the x-axis. So my value for a is 10, my value for b is negative 13, and my value for c is negative 3. We're simply going to plug these values into our quadratic equation. So the opposite of b is the opposite of negative 13, which is 13, plus or minus the square root of b squared, which is negative 13 squared, minus 4 times a, which is 10, times c, which is negative 3. All divided by 2 times a. Now 2 times the value of a, which is 2 times 10. Okay, so let's simplify. 13 plus or minus the square root. 13 squared and negative 13 squared are the same. They got to be a positive number. It's 169. Minus, well, it's actually going to be plus because we're taking a negative 4 and multiplying it to a 10, which is negative 40, times a negative 3. So that actually comes out to be a positive 120. So we're going to add those two together, all divided by 20. Okay, so let's simplify our radical. This is 13 plus or minus the square root of 289, all divided by 20. Now, the square root of 289 is actually 17, and there's two answers found within this. Remember this plus and minus. So our two answers go like this. 13 plus the square root of 289 divided by 20, and 13 minus the square root of 289 divided by 20. Okay, simplifying these, that's 13 plus 17, which is a total of 30 over 20. And then 13 minus 17, which is negative 4 over 20. So we can simplify these. This comes out to be 3 halves, and negative 4/20 is negative 1/5. So this is where it crosses the x-axis at 3 halves and negative 1/5. Those are our x-intercepts, or the solutions to this quadratic equation. Alright, in example 2, we're asked to solve this quadratic equation given by 3x squared minus 10x minus 25. So you'll see that it's already set equal to 0, so my value for a is 3, b is negative 10, and c is negative 25. Let's use our quadratic equation, which says the opposite of b, which is the opposite of negative 10, which is positive 10, plus or minus the square root of b squared minus 4ac. So negative 10 squared minus 4 times a times c, which is negative 25. Alright, here we go. All divided by 2 times a, which is 3. Let's start to simplify. We got 10 plus or minus the square root. 10 squared and negative 10 squared both come out to be 100. So that's 100. You got a negative 4 times a negative 25. That's positive 100 times 3 is positive 300, all divided by 2 times 3, which is 6. So 10 plus or minus the square root of 400, which is 20, all divided by 6. So our two answers here, we have 10 plus 20 divided by 6, and we have the other one, which is 10 minus 20 divided by 6. All right, let's simplify these two solutions. 10 and 20 is 30. 30 divided by 6 is 5. 10 minus 20 is negative 10. Negative 10, 6. Well, we can simplify that to negative 5/3. So our solutions here are 5 and negative 5/3. Now, let's just take a break and look at Desmos here quick a minute to show you that 5 and negative 5/3 are the actual x-intercepts of this parabola. Okay, you can see here we have the equation 3x squared minus 10x minus 25 graphed. And if we come over here and tap on each one of these individual x-intercepts, or even zoom in on them, you'll see that we have negative 1.6 repeating, which is negative 5/3, and 5, 0. So our two x-intercepts are exactly what we found for the solutions using that quadratic formula. All right, let's take a look at example 3. Now in example 3, you'll notice it says to solve, but what we have is a quadratic equation that's not set equal to 0. We actually want to move this 7 over by subtraction, so we end up with the equation 3x squared minus 4x minus 7, and now it's set equal to 0. And now we can use the values for a, which are 3, b, which is negative 4, c, which is negative 7, and we can use our quadratic formula. So here we go. Okay, so we have 4 plus or minus the square root of 16 plus 84, which is 100, all divided by 2 times 3, which is 6. So our two solutions here are 4 plus or minus the square root of 100, which is 10, all over 6. So 4 plus 10 divided by 6, and the second one is 4 minus 10 divided by 6. We got 14, 6 here, or we have negative 6, 6. So we are two solutions here, or x-intercepts, negative 1, and then 14, 6 can reduce to 7/3. So these are the two solutions of the quadratic, 3x squared minus 4x minus 7. All right, let's take a look at one final example using a story problem. It says a toy rocket was shot up with an initial velocity of 75 meters per second. The platform from which the rocket was shot is 2.3 meters high, and the rocket was 100 meters above the ground. Oh, sorry, it says when was the rocket 100 meters above the ground. So we can actually use the quadratic formula to help us solve this. Let's remember our formula from last semester here that talked about the free fall of an object due to gravity, and we're dealing in meters per second. So we have negative 4.9 t squared plus our initial upward velocity, which is 75 t, plus 2.3. Now we want to know when this projectile is at 100 meters above the ground. So we're just going to set this equal to 100. Now in order to solve this or find the solutions for this, what we can do is we can move this 100 over to the other side so that we have a quadratic equation set equal to 0. When we do that, we have negative 4.9 t squared plus 75t minus 97.7. All right, now this is set equal to 0, and now we can use the quadratic formula to find our values of t that make this rocket equal to 100 meters above the ground. So our values for A are negative 4.9, B is 75, and C is negative 97.7. All right, pause the video here and see if you can use these three values for A, B, and C in the quadratic formula to come up with the solutions for this quadratic equation. Okay, what we see is that our two solutions lead us to 1.43 seconds and 13.86 seconds. Because that rocket is going to sky up into the air and then come back down, there's actually 2 points along its flight that it reaches 100 meters above ground level.